In this video, we're going to talk about Hamilton paths and Hamilton circuits. Let's start with a Hamilton path. This is a path that contains each vertex of a graph exactly once. So let's look at the graph below. So a Hamilton path would be what? A to B, B to C, C to E, and E to D. Again, each vertex is touched once. Another Hamilton path would be the following. We could do C to B, B to E, E to D, and D to A. So notice with both of these Hamilton paths, not every single edge or segment is included. Okay? So here's the difference. Euler paths are concerned with visiting all edges or line segments, or Hamilton paths are concerned with visiting all the vertices. All right, so let's determine a Hamilton path for the graph below. I'll start with A. I can go A to B, B to C, C to F, F to H, H to E, E to G, and G to D. That's an example of a Hamilton path. Another Hamilton path, I can start with G. I can go G to D, D to E, E to H, H to F, F to C, C to B, and B to A. So those are two examples of Hamilton paths. Can you find others in this diagram? Okay, now we're going to talk about what's called a Hamilton circuit. This is a path that begins and ends at the same vertex and passes through all other vertices exactly one time. So let's take a look at the graph below. A Hamilton circuit would be A to B, B to C, C to E, E to D, and D to A. Start at A and finish up at A. Another Hamilton circuit, I'll start with C. I could go C to B, B to E, E to D, D to A, and then A to C. Again, starting with C and ending with C. So again, for an Euler circuit, the path must include every edge, aka line segment, and must begin at and end at the same vertex. In a Hamilton circuit, the path followed must include every vertex and must begin and end at the same vertex. Okay, let's determine two Hamilton circuits for each graph below. So I'll start with A. So I can go A to B, B to C, C to E, E to D, and D to A. Starts with A and finishes with A and touches every vertex. Another one. Let's start with B this time. So I could do B to A. I can do A to D. I can do D to E, E to C, and then C back to B. So again, starts and finishes at point B or vertex B, and every other vertex is touched exactly once. Okay, let's take a look at the next example then. So this one's a little bit more involved. So I'll start with A again. So I can do A to B, B to E, E to F, F to J, J to I to L, L to K, K to H, H to G, G to C, C to D, and then D to A. So again, I start and finish at A, and every vertex is included here. Okay, let's start at another vertex. I'll start at I this time. So I to J, J to F, F to E, E to B, B to A to D, D to C, C to G, G to H, H to K, K to L, and L to I. So again, every vertex goes through once, except where it starts and where it finishes, which in this case is at vertex I. So you might be wondering which type of graphs are guaranteed to have Hamilton circuits. Well, complete graphs are guaranteed to have this Hamilton circuit. A complete graph is a graph that has exactly one edge between each pair of its vertices. Here are some examples of complete graphs. For instance, there's only one edge that connects A and B, one edge that connects B and C, and one edge that contains C and A. And that works for the other pictures that are involved here.